stress on a system is manipulating the pressure. So, quick reminder about pressure. Pressure is the result of gas molecule collisions. So, more collisions, more pressure, less collisions, less pressure. In order for pressure to stress or disrupt the equilibrium of a system, okay, there needs to be two criteria need to be met. First off, there needs to be at least one gas present in the system, either a reactant or a product, and there needs to be unequal moles of gases. So now so if you add pressure, okay, so that means you have too many collisions happening, you shift from the high mole side to the low mole side. If you decrease the number of gas molecules, you decrease the number of collisions, then you will decrease the pressure on the system. So if we apply pressure, the system has to deal with it, and the way that it deals with it is it favors the side of the reaction. We want to decrease the number of molecules, so decrease the number of molecules. Well, if there's less molecules, you decrease the collisions, and if you have less collisions, you ultimately decrease the pressure. So let's take a look at this system here. So we cause an increase, we apply more pressure to the system. So the first thing we look at, number one, is there at least one gas present? Gas, gas, gas. So yes, we have a gas. Now we need moles. So we take a look at the coefficients. So on the left-hand side, we have 2 moles, and on the right-hand side, we have 3 moles. So we have 2 moles and 3 moles. So does the system shift? Gas present. So gas present, and we have 2 moles on the reactant side versus 3 moles on the product side. If we have added pressure to the system will shift from the high mole side to the low mole side. So product side in this case is high, the reactant side is low. So the system is going to shift from the high mole side to the low mole side, and in this scenario, that means that the system is going to shift left. Okay, so here we go. Why does it shift that way? Well, there's too much pressure. So if there's too much pressure, therefore there are too many molecules and collisions. So there are too many collisions. So the way that the system deals with this is to reduce the number of molecules. So therefore, the system wants to decrease the number of molecules. So if you decrease the number of molecules, less collisions. Well, so in this scenario, the reverse reaction is favored. The products are used to make more reactants. So as oxygen reacts with SO2, we go from 3 moles and forming a side with only 2 moles. So O2 is consumed in this shift, so its concentration decreases, the same thing as the sulfur dioxide, but these atoms in these molecules don't disappear. We see them reforming as sulfur trioxide. So we see an increase in the reactants. And as a result, now we have less molecules, less collisions, and a drop in the pressure. So take a look here. The stress is a decrease in the pressure, okay? So when we take a look at our system, does the system's equilibrium get disrupted or stressed because a drop in the pressure of the system? Well, there is at least one gas present. On the reactant side, we have 2 moles. So 2 moles on the reactant side compared to 3 moles on the product side. So it's unequal. So gas present, unequal moles. And in this case, because there's a drop in the pressure, the system needs to replace the pressure. It needs to build the pressure up. So in this case, if it's a drop in the pressure, it's going to shift from the lower number of moles towards the higher number of moles. So in this case, the system will shift right. Why? Because there's not enough pressure. So there's not enough pressure because there's not enough collisions. So, therefore, the system, in order to have more collisions to raise the pressure in the system, it needs to increase the number of molecules. It needs to increase the number of molecules. More collisions, higher pressure. So the product side has more molecules or a higher number of moles. So in this case, the forward reaction is favored, where the reactant decomposes into the products, making more molecules. So the reactant is consumed, so its concentration is decreased. The molecules on the product side are being formed, so their concentration increases.